.NET Core 3.0. That was last month. We had a big online conference called .NET Conf, where we stream a whole bunch of sessions. If you missed that, you can watch them all on YouTube and see all the things that the product team presented, and also a bunch of really cool community-based presentations. But if you missed it, the things that are new in .NET Core 3.0, we've now added desktop app support, so you can build WinForms and WPF applications using .NET Core. For Windows only, it's not a cross-platform story there, but you do get the benefits of having a standalone runtime. Like if you want to package the entire .NET Core runtime and the libraries that it needs into a single exe for your WinForms or WPF app, you can now do that with .NET Core. And you get to take advantage also of all the new features that we're adding to .NET Core that are a little harder, unfortunately, for us to bring to .NET Framework. .NET Framework is sort of this big monolithic thing that every time we update it, we pretty much have to update it in place, which of course then risks us impacting all your other apps that are on the machine using that version of the .NET Framework. So we're very cautious about the updates that we make to the .NET Framework these days. Still supported, still part of Windows, but with .NET Core, because we have this side-by-side versioning capability, we can move a lot faster and we can add a lot more functionality there. So that's what self-contained exes is all about. You can take your desktop app and link it down to a single exe. Full stack web development with C# and Razor, also known as Blazor. That's available with .NET Core 3.0. I know that's been available as was an experiment initially, and then it moved into official preview. It is now a shipped thing, at least the Blazor server version of it, with .NET Core 3.0. The component model is there. If you don't know what Blazor server is, that's where you set up a WebSocket connection with the browser and you manage the UI real time over that connection. So if you want to build a Blazor app today, you can with 3.0. And then all the C#8 language features are in there, a bunch of other good stuff. You should check it out at .NET Get Core 3. .NET is doing really good. It's a lot of fun to work on, honestly. I've been working on .NET now for well over a decade. We have well over 1 million .NET Core developers, and then of course a whole bunch more .NET Framework developers. It's all open source, publicly on GitHub. You can watch everything that we do. We just passed the threshold of 100,000 accepted community pull requests, which is pretty amazing. So thank you to everyone who sent us a PR and helped make .NET even better. It really is a community effort, not just a Microsoft effort. .NET Core 3.0 is going gangbusters. In the first month, it's only been a little over a month now that we shipped it, and Scott Hunter, who I'm his replacement here today. I'm sorry for everyone who was expecting to see Scott Hunter and was wondering, who is this guy? Scott had an executive review with Mr. Guthrie, Scott Guthrie, and he decided that he couldn't tell him no, so he asked me to come instead. But Scott Hunter was at Ignite last week, and he let everyone know that in that first month, we already have 2/3 of the .NET Core developers have already moved to .NET Core 3.0, which is amazing. .NET Framework, users tend to get stuck on a version for years. They can't move forward for whatever reason, for a variety of reasons. With .NET Core, you really get that agility to be able to move forward because you can version side by side. You can deploy standalone. We have a lot of customers that are using .NET. UPS is using Xamarin for their mobile applications. I think it's Lightsail that's using some of ML.NET's capabilities for artificial intelligence, and a whole bunch of others. Stack Overflow is on there. I actually work directly with Stack Overflow on their migration to .NET Core. They're in the process right now of moving to .NET Core 3.0. A bunch of their infrastructure internally is already on .NET Core 3.0, and they are super happy. I think stackoverflow.com, I don't know if that's actually fully made the transition, but it's at least in progress if it hasn't already happened yet. It's enabling them to do some of their enterprise offerings packaged as containers, which they view as just critical for their business. So they're super pumped about that transition. So lots of people using .NET Core. So what I want to talk about now is microservices and building microservices with .NET Core, which is a big emphasis for us. Microservice-based architecture is supposed to give you a whole bunch of benefits. You break apart your application. Instead of it being a single process, a single monolith, You break it apart into a bunch of multiple services, microservices, a bunch of different processes. And that enables a bunch of things. It's much easier to deploy. You can deploy just parts of your application. Those different parts of your apps can be on really any technology you want, because they're all just talking to each other through some sort of contract. If that one's on Node and that one's on .NET Core and that one's on whatever, that can work just fine. You get better resource utilization because you're taking advantage of your hardware a little better by having things be a little bit more granular. And for really big apps, it helps scale the development, because you can have individual teams focus on each of those services and just own that one service and deploying it. So lots of benefits with doing microservice-based development, and we want to make sure that .NET Core is really good for building microservices. Now on Azure, we also have cloud offerings to help with microservice-based development. Azure Kubernetes Service is one of the services I'm going to be highlighting today. This is managed Kubernetes in the cloud. It has all sorts of dynamic scale capabilities, and on Azure, we will manage a cluster for you that you can then just easily deploy to. In the framework, we have a bunch of new features in 3.0 that also help with microservice development. We've added some new ways for you to actually create your services, to create the endpoints. One is we've now added support for gRPC. gRPC, if you don't know, stands for gRPC, Remote Procedure Call, Remote Procedure Call. Thank you. Wow. I want to say Remote Procedure Call Protocol. The G does not stand for a company that shall not be named. It stands for gRPC, which is interesting. But if you don't know gRPC, gRPC is a high performance protocol. It's optimized for like backend service to service calls. It uses protobufs for the wire format, which is a tight binary format. It leverages HTTP2 and HTTPS. So it's really great high performance protocol if you're trying to do communication between your microservices, for streaming and all sorts of other great cool things. So we now have built-in support for gRPC in .NET Core 3.0. And that's kind of interesting effort, because there already was .NET support for gRPC that was being worked on by the open source ecosystem and community. We just wanted to make it more integrated and seamless with ASP.NET Core and have a better client code generation experience in Visual Studio. So it was actually a collaboration. Like, we worked with that community to improve the libraries and add the integration bits so that it would work great with your ASP.NET Core apps. Worker services is also a new feature in 3.0. This is a capability of having a long-running process that gets all of the benefits of what ASP.NET Core has given you historically. You get services for config, for logging, for dependency injection. You get all those things in a lightweight hosting model, but without the need of actually hosting an HTTP server endpoint. I mean, you can still in a worker service. If you want to put a web API in your service, you can absolutely do that. But you could also have a worker service that just sits there and pops messages off of a queue, or does whatever work that you want, does maybe some batching work on some timed interval. And then lastly, in the web API space, we now have support for client code generation for open APIs, or web APIs that produce an open API spec. And we did a bunch of work around authentication for APIs as part of our SPA templates. So you can authenticate calls to your APIs using specifically Identity Server, which is another great open source project. Why would you want to use ASP.NET Core for your microservices? Well, one great reason is performance. This is a snapshot of the latest Tech Empower benchmark numbers from last week. Like, I grabbed this just before I did my Ignite talk. If you're not familiar with Tech Empower is a public website. You can just go browse to it and look at these benchmark results. And it's a set of standardized benchmarks that people then contribute implementations of in an open source manner. And it's a way to sort of cross-compare every web stack on the planet to see how well they perform. This particular benchmark is the plain text benchmark. It's just how fast can you return hello world? And it gives you sort of a baseline idea of what is the underlying server pipeline capable of without any other overhead on top, without your app, basically. Just how fast can how many messages can I pump out of this thing? And as you can see, ASP.NET Core does very well on this list. We're in the top 10. I only grabbed the top slot. Like, there's a whole huge list. Like, Node is somewhere somewhere down there, and like Java server pages somewhere down there. There are some Java stacks up here though, like has anyone, what is this one? This one is Ferenio. Does anyone know that one? What's the one you know? Does anyone do Java? Do we have any Java developers here? Yeah, do you recognize any of the Java stacks up there? I don't know any. I
don't think any of them are Java.
No, there's
C++, C++.
Java.
Oh, that guy, Ferenio.
Firenio. I don't know what that is. And then this bottom one, Rapidoid. Yeah. No. I think so. I suspect that some of these, like, and there's a bunch of C and C++ ones at the top. Like a lot of the implementations at this level of the stack are frameworks that are kind of one-off, highly tuned to the benchmark things, more academic things, which is why we're kind of really happy that ASP.NET Core is sitting here, because like that is an actual ASP.NET Core app. Like it is optimized, but it is the thing you actually would use to build your applications. If anyone though finds out about any of those other frameworks and knows of actual usage of them, let me know, because I don't know any of them, which is kind of interesting. So that's kind of fun. And then our performance just keeps getting better. These are performance numbers between .NET Core 2.2 and .NET Core 3.0 for all four of the Tech and Power benchmarks. So the first one's plain text. The second one's just like return a JSON payload as fast as you can. And the third one is a different implementation. We have two different implementations of that for ASP.NET Core. And then the last one is Fortunes, which is a sort of a more real world scenario where there's an actual database involved and an endpoint. But across the board, you can see that our performance has increased dramatically in this release. 23% requests per second throughput improvement on plain text, dramatic drop in time to first request, that's TTFR. And huge drops in the working set memory needed to run these benchmarks. How did we do that? Well, we reduced allocations. The plain text benchmark is now completely non-allocating. And we added a new routing implementation in 3.0 called endpoint routing, which is much more efficient than the previous routing implementation. The previous one's still there, but the new one is what we now recommend. We have a new JSON serializer in 3.0. System text JSON, which we are now recommending over Newtonsoft JSON or JSON.NET, just because it's highly optimized for performance. It supports full async across the serializer stack. And then the runtime team did a bunch of really good work as well. They added tiered compilation support in the JIT. That really helps your time to first request, like your startup performance. And then they improved the initial GC memory reservation defaults. That's what really brought down the memory allocation needed to run these benchmarks. So fast. .NET Core is super fast. Okay, let's go look now at some code. Let's build some microservices. I'm going to look at using ASP.NET Core to build some things. Okay, so I have the latest. Actually, I have an internal build even of this version of Visual Studio should ship, I think tomorrow morning. So yeah, you guys get a free, early look at the new version of Visual Studio. That's not what it's doing. Okay, so here's what we're gonna do. But by the way, if you don't have .NET Core on your machine and you don't know how to go get it, you just go to .net. Did everyone see that? .net. That's a real thing. And it brings you to the .NET homepage where you can download the bits or get started, and that's how you can get the .NET Core SDK on your machine. You can do that on your Mac, on your Linux machine if you want, on your Windows box. You can get Visual Studio, Visual Studio Code, Visual Studio for Mac. All those work great with .NET Core. So I've already done that. I have Visual Studio, which brings .NET Core with it. So I'm going to create a new microservice. To do that, I'm going to use ASP.NET Core. And my first microservice. Okay, let's create that. And I'm going to select empty. And I'm going to pick 3.1. I'll pick the 3.1 is the version of .NET Core that is almost out. Like should be, I think preview 3 is coming out tomorrow as well, and then it'll GA on November. We said it would GA in November, so I think it's November 33rd. Maybe first week in December, I think, is when it's actually going to ship, but it's pretty close to November. Okay, so we're going to create a new empty ASP.NET Core web app. And now, when we talk about microservices, a lot of people have some impression that a microservice means that the amount of code is incredibly small. Like, oh, it's got to be like 100 lines of code, or you got to have just a few. One method is my whole microservice. And yeah, sure, that could be a microservice. Very microservice. But from what I understand, microservice. Then it's a bit of a misnomer. It is intended to drive home the idea that the service should be small enough that a reasonable sized team could manage it. Like the 2 pizza team rule is what people often use. You should be able to feed the whole team working on a microservice, one microservice with just 2 pizzas. That's about how small it should be. But that service could still have significant functionality in it and significant complexity. Doesn't have to be just 10 lines of code. But some people, when they're evaluating microservice frameworks, they want to see that, can I build something just super simple? Like, how simple can it be? So this is kind of the simplest ASP.NET Core app that you can build that has an endpoint. It's not actually the simplest, but it's simplest to create, file new project. And so what do we got here? So the ASP.NET Core app is just a console app. So static void main function. This piece of code here is just boilerplate that's setting up the ASP.NET Core host. That's the thing that starts and stops the server, so that's listening for requests. So it's building a host builder, creating the host and starting it. And then your app is defined by this startup class. So let's go look at our microservice startup class. The first method up here is where you would register services that you want to be available through dependency injection. And then this second method is where you define your request handling pipeline. Like, what do you want to happen when a request actually comes to this app? And then we have routing set up. We have the new endpoint routing system, and we're mapping all requests to the root of the app to return hello world. Okay, and if we run this, we should see, not surprisingly, hello world. Okay, and we can add more endpoints to our app, like if we want to route to other stuff, like we can route food and return a very loud bar, in which will say, refresh, this should still say hello world at the root of the app, and then if I go to foo, I should now see bar. Okay, so that's how easy it is to create an endpoint in ASP.NET Core. If you've ever seen like a Node plus Express.js demo where they just show you a Lambda method where they return something in response to an HTTP request, that's the equivalent demo in ASP.NET Core. We can do the same thing. Now, normally when you're building APIs with ASP.NET Core, you don't typically build them this way because this is a bit low level. Like all you're getting here is this context object, which has the raw request and then returning a raw response. You are getting routing, which is nice. But we have other patterns that let you have a proper class, and you can have serialization and deserialization handled for you, and validation and all those niceties. We'll see that in just a minute. But this is sort of your simplest bare bones microservice that you could possibly build. Now we do give you all of the niceties that you need for managing a microservice in a clustered or cloud environment. So there are abstractions for config, for logging, for DI. And other concerns like health checks is one, for example. Like you want to know that your microservice is healthy and up and running. Maybe you're checking that the database connection is live, or just that the app is not running too slowly, those types of things. So you can add health checks to this microservice really easily. So I'm going to add some services to my app. I'm going to add the health checks services. That's above. And then down below, let's add another endpoint. This one will be map health checks, and then I can decide what URL I want my my health endpoint to be at. Now, if I save that and then refresh the app, by default, this will just give me an endpoint that always returns healthy, because if the process is up, then it assumes that it's healthy. So if I now browse to health, then healthy, great. But you can do more interesting things here with health checks. Like if you want to add more complex logic, you just say add check here, and then you can put whatever logic you want. For example, I have a little simple example where we just randomly say we're healthy or unhealthy. So it would look something like this. And then we add a using statement. There we go. So here we're adding a check. It has a name, which I'm just calling it random. And all it does is generates a random number between either 0 or 1. If it's 0, then it returns healthy. Otherwise, it returns unhealthy. So you can write, the idea here is just to show that you can write your own logic. You can check for whatever you'd like to say that your app, your microservice is currently healthy. So if I go back And now if I just start refreshing a lot, and sometimes it's healthy, sometimes it's not healthy, and so forth. There are wonderful open source libraries that provide all sorts of health checks that work for all sorts of things. Like this project here, ASP.core.diagnostics.healthchecks, is based on a thing called Beat Pulse, and they implement a whole bunch of health checks that you can just add to your ASP.NET Core app by just saying add check on that method for like checking to see that your SQLite connection is good, or checking that Amazon S. Let's not talk about that one. How about Kafka, MongoDB? You get the point. So lots of different health checks that you can add. Okay, so that's like the simplest microservice you could possibly build. Let's do something a little bit more involved. We're going to create a proper web API now. So let's do next. Let's call this Pets API. We're going to build a Pets API. That's good. And we'll pick the API template this time. Okay, now this, by default, is not actually a Pets API. It actually has a little weather forecast API in it. I'll show you what it does. So here now, instead of having just a Lambda defining what you want to happen with requests, we have a proper controller. And you can take services in its constructor. Like here, we're getting the logger, so we can log things, and we can provide providers for that logger that will work in Azure or whatever your environment is. And this controller has just a single get method that you can call that returns some random weather forecast data. Okay, and so if we run this, you can see we get a bunch of a JSON payload returned based on our strongly typed objects. That's a bunch of weather forecast data. Okay, I don't want a weather forecast API. I want a Pets API. So I'm going to delete this, and then I'm going to add a new controller. So add controller. Oh, wait, hold on. Before I do that, I'm going to define a pet type. So I'm going to add a class, pet.cs, and my pet will have an ID, because everyone stamps IDs on their pets, right? Put a barcode on your pet side. It's going to have a name, and it's going to have a kind. What kind of pet is it? Now we'll add a new controller, a web API controller, and we're going to use Entity Framework for actually storing pet data in a database. So we'll have actual proper CRUD operations against our API. So let's add that. And then here I pick which model I want to use. I'm going to use the pet model. We're going to create a database context for managing the access to the database. And then it will generate for me a pets controller that uses that database context to manage my pets. So this is our scaffolding system. It will scaffold out the API for me, writing code for me so I don't have to. Storing a bunch of packages, generating code. Oh man. You can stop now. Okay, great. Okay, so now we have an actual pets controller. So here it has a route. So this is going to be at API / and this bracketed thing. That's just saying the name of the controller, whatever the name of the controller type is. So this would be at API / pets. It'll chop off the controller suffix. All right, and then again we have injection into the constructor. We're getting our pets API context for accessing the database, and then we have all sorts of action methods now. I can get all the pets. I can get individual pet. I can update an individual pet. I can create pets, and I can delete pets. All right, cool. Now let me just change what the startup URI of my project is, because I think it's still at /weather. I don't want it to be at /weather forecast anymore. And if I run this, it'll just 404 at the beginning. And if I go to API pets, right? Oh, then it's going to say you don't have a database yet. So we need to initialize the database first. And that just means running migration. So I will do that really quick. So we want to add a migration. Call it initial. Entity Framework Core gives you a convenient way of migrating your database as you make schema changes, and you can also use this as a way to initialize the database. So update database with that migration that I just created, and that should create a database for me now. Wait for that to create the database. There it goes. Okay, let's rerun that. Okay, so now if I browse to API pets, we have a grand total of no pets. All right, cool. Now with my weather forecast API, that was doing a GET request with a browser was all I needed because it only supported GET. But now I have like post and put and delete. Like, how do I test this thing? How do I actually find some convenient way to work with my microservice? Well, one way we can do that is we can enable support for Swagger or the OpenAPI specification. If you're not familiar with that, it's a standardized format for describing a web API. And there's also a default UI, the Swagger UI that you can use to interact with the API. So that's convenient. So I'll just do that real quick. There's a package that we can use for that. I'm going to use nswag for setting up OpenAPI support. There's a couple of packages out there. Another one is Swashbuckle. They're all just fine. So I'm going to add nswag ASP.NET Core, and I want this version. Unfortunately, 2 hours ago, there was a bad package released for this. That was, I'm glad I caught that before it was demo. Hopefully Rico Sutter's the name of the guy. Oh, wait. That was the error. Did he just push another one? Wait, hold on a second. Hold on. Let me see, let's see. Like in my script, I had used one version backwards. Don't, is there, yeah, so he just pushed an update, probably to fix the bug that I just hit before, and so now I gotta go let's see if I stay. This is not a Microsoft owned package, by the way. This is, again, open source community just doing its thing, and hopefully this one is better. Otherwise, we'll go back 2 versions. There we go. Awesome. Hey, they're fast, man. Better support than, I don't know, Comcast. All right, let's now enable my OpenAPI doc. So I'm going to add his services. So add OpenAPI doc services. That just sets up the code that's needed to generate the document. And then I'm going to add 2 endpoints to my app. One for the actual machine-readable description, and then the other one for the user-friendly UI that I can use to interact. So app.use OpenAPI and app.use Swagger UI3, I think is the latest one. Okay, great. And I don't know if I need to run this. Let's just run it. Okay, and now if I browse to /Swagger, woo, that's big. Okay, so here we get an endpoint in our app now that serves up this UI. I can see my entire pets API, and I can even like try it out and execute things and see that, yes, I still have no pets. But if I wanted to add some pets, I could call this post action, try it out, pass in a payload here, and clicking my way to victory, I could start adding pets. So that's nice. There's also another tool that we also recently shipped that we call the HTTP REPL. It's a REPL environment for interacting with HTTP services, and it knows about OpenAPI specifications, so it can read that and help you then navigate the API. Now, the way you get it, I think this is the special URL. It's aka.ms/.NET Core/HTTP REPL. aka.ms.NET Core, I think that's right. Yeah, okay, now bring it to our docs. And this talks you through what this tool does. But the one command you need to run to get the tool is this one right here. So .NET tool install -G and then the name of the NuGet package that carries the tool. If you're not familiar with global tools in .NET Core, they're pretty cool. They're kind of similar to global tools in Node, where you can like create a little command line tool, package it up as a NuGet package and install it and make it available on the command line. So if I open up a command prompt here, and if I run that, it says I already have it installed, so that's good. So I can go ahead and execute it, HTTP REPL. And it's going to start in this disconnected state. If we type help, we can see all the help messages for it. So we can use the REPL to issue any HTTP request that we want. We can connect to a service. We can set headers. We can use sort of like LS and CD style navigation to browse through the paths of the API. And you can even do like set up scripts to have the HP REPL run if you want to use it as like a testing tool. Okay, so let's connect it then to our API. Let's see, this is probably what we want right there. So connect to that. And you can see that it detected that there's a Swagger document, an open API spec for this API. And now if we do an LS, it knows there's an API path. So let's go into API. If we do another LS, okay, there's pets. All right, and then if we do a get right here, it issues the get request at that path and returns no pets. Let's try and do a post. And it brings up my favorite editor for creating our JSON payload. Let's create a pet. Let's call it Fluffy. It'll be a cat. And then just save that and close, and then it will send that in the request, and then I got a response back. And so now we have Fluffy the cat at ID 1. That's kind of cool. So we can get Fluffy. So get 1 is passing that path, so like lets you get the cat. And we can update it. So let's update Fluffy. Yeah. So I want to update number 1. Actually, Fluffy was not a cat. It was a tarantula. Fluffy too, right? And if we get 1 again, yeah, same works. Okay, so that's a nice way to interact with your API. And in fact, if you want to make this like your Visual Studio experience, that's pretty easy to do. So if I'm going to exit out of this and just ask like, where is HP REPL? And it'll give me the full path to the executable for that was installed. And if I grab that, I can close this now and go to Visual Studio. You can say browse with, and then add, and then you can put in the program you want to use, and you don't need to put in any arguments here. And then that will become an option as like a browser for your web API. And I've already done that. Like you can see I've got HP REPL up here. So if I browse now, it automatically will connect, and then we're good to go, and you can do the same sort of things. If I control F5, it'll, that's not what I wanted. I want to say my browser is now HP REPL instead of Edge Beta, and now if I control F5, voila, it just popped up the REPL. And then you can, hello. Is there a question there? Okay, all right. Hello, can you hear me now?
Yes, thank you.
Okay, was that muted all this time?
No,
No, just recently. Okay, good.
Mickey hit mute all when we had the
Can you go
audio.
back to the beginning?
Yeah, start again. Do it all again. Okay. In the interest of time, I have the code for getting the pets using this client right now. I'm just going to copy it so you can see it. But it's pretty simple. Like now I can just new up a pets client. That was what was generated for me from this Swagger document, which it copied into my console app. Go back. And then you do have to give it an HP client. That enables dependency injection. So like if you wanted to put this in DI and have the HP client also be configured through DI, you could do that. And then we just call get all the pets, and then we can loop through them. So let's see if this works. So I'm going to set this as the startup project, and let's see. Ta-da, we got Fluffy. Okay, let's see that. Okay, so that's how you can generate API clients.
If you change something on the server side, how does it update the client?
So you can, so it is putting a manual copy of the OpenAPI spec into your project. There's a gesture where you can say, please refresh it and grab it anew. You can also just point to a file. Yeah, it will rebuild the code based off of that spec on every build. So it's a build time code generation pattern.
Does it have to be in the same solution?
No. In fact, you saw I pointed at a URL. That URL could have been anywhere. It doesn't know.
Okay.
All right. So next, I will show you a different kind of endpoint that you could create. Remember, I mentioned that we now support gRPC. Let me show you how you can create a gRPC service. So we have a template. Just create a new gRPC service. gRPC service 1 sounds like a lovely name for my gRPC service. Let's create that. Now, gRPC is great because of its efficiency. It's a nice modern protocol. It does have a couple of limitations that are good to be aware of. Well, I guess I should say there are some limitations of like IIS and certain environments that you should be aware of with gRPC. gRPC relies on trailing header support. Like, you know, on HTTP requests, normally you put the headers at the beginning. Well, gRPC sometimes puts them at the end, which is a thing, I guess, with HTTP2, which gRPC utilizes. IIS does not yet support trailing headers. It does support HTTP2, but just not the trailing headers part. And it actually is an issue all the way down at the HTTP sys layer. So they're working on that. That will get addressed with like a Windows update in, you know, some number of months from now. But it means you can't actually host a gRPC service as is in an IIS-based environment today. Yeah.
Why would I use IIS? This is a cross-platform thing, right? So they don't make that for Linux.
Right. So you're absolutely not required to use IIS. If you're on Windows, the value of IIS is it does like process management for you. And there's a bunch of native modules that come with IIS for like handling Windows auth and a whole bunch of things that if you wanted to utilize those features on a Windows machine, you could. Now, granted, you don't have to use IIS at all. In fact, this project by default, because IIS doesn't work, is set up to just run as a standalone process using Kestrel, which is the cross-platform web server that comes with ASP.NET Core. But a lot of .NET devs have been using IIS for years, and they kind of expect .NET will just always work with anything you do with .NET. And this is one of those cases where that's not actually true. Same thing with Azure App Service, actually. Azure App Service, at least the Windows version of it, is an IIS-based system. So you can't just right-click deploy a gRPC service to Azure App Service. But in Linux, like you can wrap your gRPC service up in a Linux container. You can put that in a Kubernetes cluster and use Kestrel as your server, and that works great. Okay?
And the benchmarks you showed earlier were from Kestrel.
Yes, in fact, yes, absolutely. There was no IIS in the picture there at all. Yep. All right, so we have a gRPC service. This is what it looks like. gRPC, you define the contract of your service using this proto file format. So here, this is saying that I have a service called greeter. It has a single procedure that takes a hello request and returns a hello reply. And then the structure of the messages are defined below. And those could be, you know, complex types with all sorts of things. This is not C#. This is another format that you do need to know to work with gRPC, at least as we've currently implemented it, but it's reasonably straightforward. Okay, running this won't do anything. It'll just be an endpoint that doesn't return anything. So I need a client, and you can do the same trick that we did with a web API.
You said gRPC was highly efficient for service-to-service communication.
The service-to-service communication is kind of its bread and butter. You can also do it from like mobile clients to server, like for front-end usage. But another limitation of gRPC that I didn't mention is that browsers' HTTP stacks don't have enough protocol support to speak full gRPC. There is a variant of gRPC called gRPC Web, which we have not implemented, but is that you could technically use from browsers to backends, but it's effectively a different protocol.
You said that the protobus is how it's formatted, that the messages are in.
Yeah, so the actual serialization of the messages on the wire is done using protobuf. Yep. Okay, but we can create a console client for this, no problem. I will again add a service reference, And here we'll do gRPC. This time, instead of using a URL, I'm just gonna browse right to the file. So I wanna go to gRPC service, proto, and I wanna generate client code. So normally what you do with gRPC services, you author the proto file first, and then you use it to code gen a base class for your service, which you then derive from to implement. And then you use the same proto file to generate the client code. That's kind of the standard pattern. All right. So now we've generated a client. So here, let me show you the server real quick. So here's a gRPC service. This greeter base class was what was generated from the proto file for the server. And then we are overriding the say hello method to provide our C# logic. And then on the client, the code looks like this. Okay, so here now you have to set up a gRPC channel, and you point to the address that you want to talk to, and then you create your client using the channel. So this is the greeter client that was generated for us from that proto file, and then you just call it, say hello. So we should be able to run both of these. Let's run them both at the same time. So do start, okay, F5.
And this IDE that you're showing does it only run on Windows, or is that the one that you were saying you could download and run on any platform?
Great question. So this is I'm using Visual Studio. I'm using the Windows version of Visual Studio. There is Visual Studio for Mac as well that you can use.
Is it's Visual Studio Code though, right?
No, there's both.
There's an actual.
There's both. Yeah, if you go to visualstudio.com, you'll see 3 options. So there's Visual Studio, which is the one that's been around for like ever. That's the Visual Studio on Windows. There's Visual Studio Code, which you mentioned, which is like a lighter weight text editor style pattern. And then there's also Visual Studio for Mac, which is a full IDE that also works on.
So everything that Visual Studio does, the Mac version does too?
No. But it's closer.
Everything you showed me?
Everything I showed you, like file new project, create the service. The code generation, you'd have to drop to the command line to do code generation, because I don't think they have the ad service reference in VS for Mac yet. The VS for Mac functionality is trailing behind VS right now. VS on Windows, it's been around for a couple decades. It's tons of functionality. It's built up over time. VS for Mac was based off of the Xamarin Dev. It was an IDE that we acquired from the Xamarin team when we acquired them, and we've been gradually updating it to move over all the Visual Studio functionality into it. So right now it has the full VS editor in it. It has all the web tools. It uses all the same templates for like file new project. It has the same C# editing experience, but there are other feature gaps that just haven't moved over there yet. But they will. Like that, there's the Visual Studio for Mac team's job is to make it look like the VS one. So eventually it will be completely.
Is Visual Studio Online just going to be VS Code, or will it be full on Visual Studio eventually?
I don't know how much I'm allowed to say there. Like I think the intent is for you to have a hosted Visual Studio, full Visual Studio experience,
Okay.
whether that's Mac or Windows or code. It doesn't really matter at that point. It's just like I have a full tooling experience in the cloud, so to say. All right.
The ad service stuff you're doing is in the most recent version of Visual Studio, or is it back at the version?
That one is in the most recent stable release of Visual Studio, so Visual Studio 16.3.
That's all right now.
Yeah. Yep. Okay. So did we get it? We have both. Okay. So this is the server right here, and then here's the client, and it got the response. So that's how you can build a simple gRPC service. And man, time is flying. Okay. Worker services. So this is the worker service template. Remember, this is supposed to be for, you just want to have a service that's a long-running process. It may not even have an endpoint. Like maybe it's just pulling from a queue. That's what this guy is for. So I'm going to call this one worker service 1.
How is that different from an Azure function?
From what function?
Azure function?
An Azure function. Well, Azure functions pretty much have to run in the cloud, right? Whereas worker services You could run them locally. In fact, I'll show you some ways that you could run worker services. You could run them as a Windows service or using systemd on a Linux machine or a Mac machine. So here's what they look like. The program main looks pretty similar to what you saw in an ASP.NET Core app, except we're not building a web host. We're just building a generic host. And then down here is our worker class that actually defines what we want our worker to do. And it has basically methods that you can override for start, stop, and execute. So fairly simple. And you can see that this one, all it's doing is starting a while loop and logging every second a message that it's running. That's all it currently does. But the nice thing about this model is that if you're building a long-running process, this will give you config. This will give you logging support. It gives you dependency injection, all the niceties of ASP.NET Core, but in a real slimmed down fashion for these just long-running worker processes. So if we run it, there's nothing too surprising. It just spews out a log message every second. So there it is. And I'm just going to stop that. Okay, but you asked, like, how is it different from an Azure function? Well, in this case, I can host it, say, like as a Windows service. To do that, I'm just going to add a single package. Microsoft, this one. Microsoft Extensions Hosting, almost Windows, well, it's right below, Windows Services. And sure, let's do a preview package. What could go wrong? That's great. Actually, is this, I can't remember if I'm using 3.1 or 3.0 for this worker service. 3.1, okay, yeah, so it should be fine. All right, and then we just have to add a line of code. We just say use Windows service. And if you're doing systemd, there's a similar package for systemd that you would do use systemd. And that would work on other platforms. Coolio, okay, so I'm going to publish this now. Publish in .NET Core is how you like take all the build assets and collect them all together into so that you can then deploy it. So I'm going to publish to a folder, and let's publish to worker 1, and go. Okay, and now we should be able to easily create a Windows service out of this. Let's, I'm going to get an admin prompt because I'm actually going to create a Windows service, which requires admin privileges. And if I do dir worker 1, I should see my app. There's all my stuff. There's the worker service I just created. I want this executable to be used to create my service. And I don't remember these commands off the top of my head, so I'm going to copy them. So let's see. Yeah, this one. So I think this is like service control is the name of this tool. I don't know. SC create worker 1 is how you create a Windows service for those of you who don't know, and I didn't know. All right, and then we want to SC start worker 1. Good, so that looks promising. And now on Windows, if I go look in here in the services UI, I should see a service. And there it is, worker 1's churning away. Now, I just remembered I forgot to do something. Let me stop it. So SC stop worker 1. I want to up the log level a little bit on this guy because one of the nice things about using worker services as a Windows service is that they log right to the event log. So if I log critical instead of that, and then if I go back to publish, let's publish this again, using the same profile. Okay, I think that's all I need to do. Let's start it again. Okay, now if I go, is it started? Let's see. Action, refresh.
Down there.
Further down. Thank you. Okay, so it looks like it's running. Looks like it's good. And now if I go to the event viewer, we wire that up for you so you can get logging output. Wait a second to read the events. Yeah, so I've got all these terrible errors saying, you know, worker service 1 has run. So I don't know if I get that next call from one of those, you know, scam people saying like, there's something wrong with your computer. Go look at your event viewer. I'll be like, oh my goodness, worker service 1 is like going haywire. All right, so that's how you can really easily turn a worker service into a Windows service. And you can do, like I said, you can do the same thing cross-platform with like systemd. Okay, now we can take any of these projects that I've shown you, you can take them and turn them into a container. Like you can wrap them up using Docker and deploy them into a container registry, into Kubernetes. And it's pretty easy to do. You can just right click and Docker support. Is this gonna work? Hold on. I think 3 1. No, I'm sorry. What is it? Is this the one I'm not supposed to do? Yeah. Oh shoot. Okay. Hold on. Let me change
It
this.
works on a Mac.
The 3.1 is in preview, and there's an issue with the Docker tooling right now in 3.1. So I need to just quickly create a new worker service. We'll call it worker service 2, and this one is going to be a 3.0 that has already shipped, and the tooling is stable as opposed to being semi-stable like 3.1 is. Okay, so now we should be able to add Docker support to my worker service. And here, what's happening is it's asking me, well, what kind of container do you want? Do you want a Windows container or a Linux container? Linux container sounds great. You might wonder, like, wait, you're on a Windows machine. But actually, I have Docker for Windows installed on my computer, and it will set up a Linux host VM using Hyper-V, and then use that as a Docker host for Linux VMs. All right, and so now notice up above my play button, it says Docker. So if I F5 this, it should run in a Docker container. And in fact, yeah, let's go ahead and just do that. Let's look at the output while this happens. Oh, yeah, so this is cool. This is new. The new feature in the latest version of Visual Studio is this containers tooling where you can see like all the environment variables for your running container. You can see the logs. Like you can see my worker service is now running. You can see the files on the container that's running. So like if we dig in here, we can probably find the code for my worker service. There it is. That's cool. And I F5, so I should be able to debug even. So if I go into a worker and then go boop, in a second, click. Okay, so that was me hitting a breakpoint in some C#.NET code that's running in a Linux container that's hosted on Windows and Visual Studio. Isn't that fun? Okay, so I'll remove that and let that continue to run. So once you have it Dockerized in this way, like it has a proper Docker file. Stop the debugger. So here's the normal Docker file. We have all sorts of standardized Docker images for .NET Core. That have all of the ASP.NET Core bits pre-installed, the SDK bits pre-installed that you can just use. Now I can take this, I can do local development, is what you just saw, but I can also now publish it to any place that it would be appropriate to have a container. So if I want to publish this worker service, you can see some more options have now shown up. I no longer just publish to the file system. I can publish to Azure Web Jobs. So that's an Azure service as part of the app service offering where you hosted web jobs are things that can like trigger on different types of events and run on a regular schedule. A worker service could happily do that. Or we could publish it to a container registry. And from the container registry, you can go then to anywhere you want. Like you can go to Kubernetes, you can go to Azure container instances. I will do that real quick. So I've already set up a container registry on Azure for my account. Go there, and we can publish. And I think I might have to skip showing you this actually. I'll show you that the publish actually works, but you can then go into the portal. You can find the container in the registry and say please run it, and it will use Azure container instances to just run the container. And you can see the logs in the portal and know that it's actually running in the cloud, so to say. But because we're running short on time, and I have one more.
Currently logging to the event here, though. You publish it to a Linux container. Where's it going to log to now? In the containers, obviously, it's not going to be logging to the. So the one that logged to the event viewer was the one where I added a Windows specific package to it. And this one is a different project. I did founding project in this one, and that Windows specific package, by the way, it will know off on Linux. So if it sees that it's not on a Windows environment, it's not going to try to do anything with the event viewer because that would be silly. That would be silly.
Look at that Docker file again.
What's that?
Look at that Docker file one more time. Okay.
Does it pass muster?
It's good.
Yeah, I'm not sure about that, Dan. Is there? Okay, well, that was good for me. All right. Last thing I'm going to show with microservices
Okay, whenever you want to do like a full Kubernetes flow. So we have this lovely template here called Container Application for Kubernetes. Okay, so this will get me started with doing development locally on my machine, where the services I'm building are Dockerized, like they're gonna run in containers, but I don't actually even need to have Docker for Windows installed on my local machine, because the way this tooling works is it will set up a Kubernetes cluster in the cloud, and then all of your development is done with the services running in a dev space in that cluster on the cloud. Okay, so you don't even need Docker tooling locally. It will do everything in the cloud for you as if you're running locally. Kind of interesting. All right, let's see. So we'll call this, I want to build an API. So let's call this Web API 1 and Kubernetes demo. Okay, that. Let's create an API. 3.0 sounds reasonable. Probably wise. Don't have too many preview bits floating around for this demo. Okay, so we have an API now, and I'm going to do some of the things that we did before. Like, remember we set up NSWAG. Now we can do latest, right? Because latest got updated as of like 15 minutes ago, apparently. Okay. I have to wire that up. So I need services dot add open API document again, and I need my two endpoints. So app dot use open API and app dot use Swagger UI3. Okay, cool. So that looks good. Now, notice up above, like when instead of saying Docker this time, it says Azure Dev Spaces. So it's going to do something kind of cool when I click this. So first it's going to ask me, well, where do you want me to set up this dev space? Which dev space do you want me to put this microservice in, this API in? Now, I've already set up a Kubernetes cluster myself in my Azure subscription. And if you want to do that too, you can. Whoa, just happened. It's supposed to be a... Oh, I know what that is. That's because... Okay, that was the HP REPL. So let's switch this back to Edge. Okay, and now by F5, that was really interesting. I think it tried to open that link with the HP REPL, which was just to like documentation. That's really fun. So if you want to create your own Kubernetes cluster, that link will take you to this page, and there's this like try it button, which will then open like a Azure Cloud Shell that you can then just copy these commands from the left and to the right, and it will create a cluster for you using the Azure CLI. So I did this. It takes a little while, like it takes like 5 minutes for the cluster to finally spin up, but I literally just copied from the left to the right and filled in what resource group I wanted and what I wanted the name of the cluster to be. So if you want to try it, that's what you got to do. And then you specify what the name of the space that you want. What is a dev space is kind of like a partition of that cluster where you're going to do development in. So it's like a namespace. Yeah, sure. And I'm going to call this, let's create a new space, demo. Okay, go. So then this takes a little bit, but it will build the container, push it up into the Kubernetes cluster, run it, open all the ports necessary so that I can then access it as if it's running localhost on my machine. Hopefully. So we're actually in the output window, we can watch all the magic happening. So I did the restore, something about pods and kubectl and all sorts of complicated things. Who works with Kubernetes here? Does anyone do Kubernetes-based development? You work with Kubernetes?
Yeah.
This is what you do, right? Like you just, you do this like what?
You were building in Docker also, right? There was another project you actually tried to build in ACR, Azure to container runtime.
Yeah, so the worker service, that I had added Docker support to it, and then I right-click and published it to my Azure Container Registry. So now I do have an image sitting in that container registry. that I could run or deploy to other places. I didn't have time to do all that, but okay. So this is now running in a Kubernetes cluster in the cloud. It's not actually running localhost on my own machine, which is pretty trippy. Okay, and I should be able to get the Swagger document for it. Okay, great. And so I'm going to copy that. And then let's get even more crazy here. Let's add another project. So I'm going to add a web app. Web app. Web app 1 sounds like a great name for my web app. Yes. Okay, and what I want to do is I want to push both of these into the Kubernetes cluster, and I want the web app to call the web API, right? Call my microservice. So to do that, I'm going to right click on the second project and say add container orchestrator support. You guys see that? So there's a template that you can do to just say like, create a thing that's going to run in Kubernetes for me. And then there's a right click gesture where you can say, this one's going to run in the Kubernetes cluster as well. All right, so let's do that. Right click, add container orchestration support. And you get to pick which one you want. I'm going to pick Kubernetes because that's what I'm using. Okay, so I added all the Helm charts. Those of you who know what Helm charts are and all that stuff. I won't claim that I know all that stuff. So now I want to add a web API, a service reference from this app to the web API. I think I have to run the API again because I just stopped the debugger. So let's make sure the API is running, and then we'll add a service reference. Let's see how it's going. Step 12 of 14. Okay, looks like that worked. Waiting for container. Okay, great. So now we've got a live API. We should be able to go to our web application and say add service reference. And I will add an OpenAPI service reference to a URL. Okay. This will do the same thing that we saw before, right? Coolio. Now I want to make 2 small tweaks here. Oh, why? Why did you fail? I just ran this. Oh no. Okay, wait, hold on. Maybe the URL. Maybe I got the URL. Maybe I copied the wrong one. Copied the wrong URL. Let's get this again. Okay, so that's fine. So I must have typed in the wrong URL. So this. Good. Try again. We should see an open. Yeah, there it is. Okay, so now we've got a client, but it has one little issue with it. I got the Swagger document from an address that said localhost. But when I make the web API call, we don't want it to call using localhost. Like the generated code would otherwise have hard-coded into it, like not hard-coded into it, but in an inconvenient way to change localhost. I want it to point instead at the service that's running in the cluster from within the cluster. This tooling will set up DNS-based routing, so you can use a convenient host name, like the name of the project as the host name, and then it will just route correctly. So I'm going to change this URL in the downloaded OpenAPI spec to be web API 1, and then Kubernetes and Azure Kubernetes Service will take care of routing that correctly. And then I also want to make sure that my class name is correct. And so let me just quickly change that to something that's reasonable. Where's my OpenAPI reference? This one right here. So class name, I want this to be weather client. That's the name of the generated class that I'm going to get out of this. So let me rebuild. Okay, so that rebuilt successfully. Okay, so now I should be able to call it. So let's go into startup, and I'm going to add that web API client in here. So services, add HTTP client. And the HTTP client I want to add should be that weather client, okay? So what this will do is this will set up an HTTP client in DI that will be used for as well as this weather client that I can then get injected into my my pages and my services. So then in my home page here, I'm just gonna copy. I don't want to take too much more time on this. Yeah, this code. So I'm going to just update my index model for my home page with this code. So here I'm injecting that weather client that I just set up in DI, so I can grab it. And then when the page is loaded on get, it's going to get the weather data from the weather service and populate this weather data property. And then I need to add a little bit of UI to render that. So I'm just going to grab this chunk right here and then put that in my markup. So now when the page renders, it's going to render a table. And down here, it will loop over that weather data enumerable. Does that make sense? And it will just render out the rows of the table based off the weather data that it just got from the API, assuming this all actually works. So let's see if it does. So if I've forgotten anything. Okay, so now this is about to go up into the cluster. AKS sounds good. Demo. Okay. Let's watch the output. Step 9 of 14. So this first load then takes a little bit longer because it's not warm. Like it does do some clever file synchronization, so it can detect which files have actually changed. But the first push up takes a little bit longer. But that looks like everything's built successfully. And waiting for a container to start up. Okay, service is available on port 80. There's our Docker tooling. That actually worked. I can't believe it. Okay, what's even cooler is I think I can set a breakpoint. So this is a breakpoint locally in Visual Studio, but it's going to get hit in a service running in a Kubernetes cluster in the cloud. Okay, let's see if that actually happens. If I just refresh this. Boop. Oh my God, so you can debug and all that stuff. That's pretty awesome. Okay, so that's the new dev spaces tooling, doing Kubernetes development, microservices. Okay, I'm over time on how long I thought that was going to take. So we've got 40 minutes. I want to talk about Blazor next, but I know you guys have been sitting, been very, very patient. Do you guys want like a 5-minute break to like stretch?
Yeah.
Okay, take a quick 5-minute break. If you need to use the bathroom, use the bathroom. And then come back here as fast as you can, and we'll start talking about Blazor at 7:25. 7:25, we're going to start again. Now that's a question. I know that was really fast. If you have questions about any of that.
Do you need water?
Yeah, confusing times, Andrew, confusing times. What do you mean? Never thought I'd see .NET running on Mac. I never thought I'd see Visual Studio launching shell scripts.
Yeah.
Especially if they're
Blows my mind.
that was the. It's usually.
Wait, I think you did your day.
You're an old man now. I think.
Yeah, I don't know actually, because and
Yeah.
But even the HTTP, he has 3.2.
yeah, oh yeah, they both went to the same specs. Is that the way they're talking about?
We are. Yep. So,
You're worried about 3600.
yeah, tomorrow I actually have to go to.
Maybe.
For the day.
I need to, it's a new demo for us, so I haven't done it a lot. I haven't had a chance to really dig in with the team to understand like, what is it actually doing under the covers to make it work? It's supposed to be actually fairly snappy. Like if you control F5 and just like are changing files, it's supposed to actually watch files and push changes as you're like editing and saving things. I haven't played around with it enough to really get a feel for how well that currently works. But still, like, given what it would have taken me to set up a Kubernetes cluster and deploy into it and get services to talk to each other without that tooling experience, doing that in like 20 minutes was super cool.
You know it, yeah. Well, a quick question, I'm sorry I came late, but the benchmarks that you showed, was that one host? 3.2 million requests per second, or was it a cluster of hosts because I didn't load them?
So I
Because
think
it's pretty damn impressive. And what is it?
CPU power,
I'm sorry.
round 18 is the last official round they did. The numbers I got were from their CIs, which run much more frequently. These numbers will be a little different than we saw.
Oh, okay, it's tech and power. I thought it was an internal one that you guys did. So,
No.
yeah, they usually use multi-core clusters.
So we specifically
Single query.
go out and just deeply work.
So
with the customers on
Dell R440 Xeon Gold plus 10 gigabytes.
But secondarily,
40 was-
also
so
being
that's-
part of the engineering group, right, we're looking for that
Oh, yeah?
insight into.
4 cores?
Understanding the
I don't know.
Like it's some of the other ones.
how you're trying to do it, the environment.
I'm sure somewhere on here it tells you exactly the hardware they use. And they have a couple of variants, like there's
Okay, I'll check it. Yeah, I use the site before.
this is the cloud version.
We're working from Mill Creek last time to make it.
Yeah.
So this is an Azure
Sibling, right?
D2.
Okay.
Which ASP core is the one that you're showing?
So
I don't know.
So Scott.
There's multiples there.
So they're getting 1
Core
million.
runtime.
Yeah, we have lots of variants. So yeah, this one's actually running on normal .NET Core in this case. This one's based off of a kind of a really more prototype, RH stands for Red Hat. Like there's some low-level Red Hat thing that they did to improve the throughput on specifically for Red Hat Linux. This is the more canonical case. And then there's a couple of other variants further down the stack.
Always been in the
As you add more to the stack, more features, you obviously.
Yes, yeah,
And the numbers here are so high that even like tiny little additions like can make fairly big differences in the throughput things.
The Fortunes one's better than that.
Yeah, it's kind of been all done, but always in that space. Always got this. Fun.
I thought you guys were number 2 at one point.
We always jump in.
They change pretty quickly, and I believe with Fortunes, our main bottleneck is still the database adapter, like the Postgres hop. I mean, there was been a lot of work that was done on that adapter. Like we used to be kind of middle of the pack on Fortunes, and then the open source community really did some good updates to the Postgres database provider. And
We've used this as like a, put your money where your mouth is a little bit. It's like, yeah, Java's up there. It's like, what is that?
yeah. No, I know. I mean, Java's got some fast stuff, like Scala-based stacks have been up to the top for a while.
That's what they want us to use. It's like buried.
Yeah. Well, I mean, we should be like doing a Spring Boot to ASP.NET Core apples to apples would mean also like making sure the same number of features are wired up.
So.
All right. Go ahead. You went on.
I came out of, I went to
Catch
catch
any-
How do you handle versioning on your open API stuff?
operation system.
Okay, so do you get?
So more of a business
So
background.
I had a tool
Yeah,
that's very similar to
I
this. So
joke a lot of that.
it generates NuGet packages, and then so the clients subscribe to those NuGet packages, so you can see, and it puts in the Azure artifacts, so then I can track who's using what version of that thing, so I can deprecate old versions of that
The logic behind relationship.
in swag.
Basically,
Wow.
right, and
That's cool.
Solving.
I would say,
We knew this a year and a half ago.
yeah, but I don't have like automatic hook into it, right? And that's what I'm saying. So like, once the server updates, how do you make sure your clients don't get killed?
Yeah. I mean, in general, with loosely coupled systems like this, like you don't know, right? Like you have no idea who's calling you. And so as you change things, you have to have some sort of version strategy. Like in general, adding things is non-breaking. You can start doing a versioning protocol type of thing, like where the client says what versions it supports and the server like changes what it returns based on that. There are libraries that will help you implement version strategies like that with ASP.NET Core. We don't provide one out of the box though. It's kind of like you pick what you like.
Unless, like in that situation, someone here.
When you do that add service thing, what about services that have authentication? Do you have any problems doing that? Because like the old OData stuff they had that was like plug-in stuff and it would build out the OData stuff.
Yeah.
It wouldn't work if it was security. You had to download the XML.
So
The XML.
with both the gRPC protocol and the Open API spec, like the two patterns that it provided there was, well, where's the URL, or just give me the file. And I think for the where's the URL, it does an initial fetch, and I don't think it does a refresh on every build. Like once it's got it, it just like holds on to it.
Right, but if there's security, if there's a user pass that I have to have for that, does it allow?
I to hit the URL. I'm not actually sure. I haven't tried it. I have to ask. But once you get to the generated client,
Right.
then you provide the HTTP client to that you want the client to use. And so if you want to put authorization headers on the
for sure.
request, that's how you would.
It's actually great.
I think it depends on how you implemented your auth and auth.
What's top of
Right,
mind?
so it depends how you implemented your auth and auth. So if you're using like an HTTP module and
You
all
like,
this,
you don't like, this is also in.
you're essentially gonna hit that before you're gonna hit Swagger. So we do that.
Right, but even when I, but just the code generation piece.
Yeah,
you're gonna bring back.
Like OData, I had, like OData, I couldn't get an OData call because it didn't give me a way to put my credentials in.
Yeah,
I had to
I think
go down.
it depends on how you've done your auth and auth.
I got you.
But in worst case, if you have some other way of hitting the endpoint and retrieving the profile or the OpenAPI spec using your credentials in the browser, and then you just save it to disk,
Yeah, that's what I had to do for this.
that works fine.
And so a lot of, what we would do is we would go in and, we use HTTP modules for authentication, so you can go exclude that path. Right, so you can hit that path, that, you can get in there without getting authenticated with.
Okay, right.
It all
Yeah, the
depends.
metadata layer type.
Yeah.
Thanks for
We
having me.
got 30 minutes.
Like all
We're gonna start talking about
answers.
Blazor.
Yeah. Hey, we'll hang on later.
You're 3 minutes behind where you said that.
I know. We're gonna go ahead. Everyone who wants to hear about Blazor, come back in because we're gonna get started.
Existential conversations going on.
All right. What is Blazor? Who's already heard of Blazor? Who already knows what Blazor is? Who? Does anyone want to admit that they don't know what Blazor is? Okay, so like 2 people. Well, for the sake of everyone, just make sure we're all on the same page. What Blazor is all about is today, if you're building apps, you have an entire development ecosystem that you can use for any type of app that you want to build. You can write in C, you can write in Rust, you can write in Go, you can write in .NET, Java, Python, whatever. And you can do desktop, mobile, cloud, games, whatever. You have lots and lots of choice. And that's also true in the browser. Like the browser, there's lots of choice as well. You have lots of languages and tools and frameworks that you can use, as long as it's JavaScript. They all have to boil down to JavaScript in the end in order for it to be able to function correctly. At least historically, that's been the case. All browsers knew how to speak was JavaScript. And I actually think there's a lot to like about JavaScript. I know, I think when I looked at JavaScript 15 years ago, I was like, oh my goodness, like my eyes burn, like global scope variables, and like, but it has come a long way since 15 years ago. Like there's TypeScript now, there's ECMA script updates that make it actually pretty modern, decent language. But that said, it seems a shame that there's all these other frameworks and tools and libraries that you could use for anything else, but you can't use it for browser apps because browsers only knew how to speak JavaScript. And the good news is that the web community got together and they said, yeah, that is a shame. Like there should be a way. And so they defined this new open web standard called WebAssembly. And what WebAssembly is a standardized bytecode for the web. The idea with WebAssembly is not that you write code in WebAssembly, just like you typically don't write code in assembly, but you compile code to assembly, to WebAssembly. And as long as you can compile your code to WebAssembly, it will run in any browser now, on any platform, at near native speeds. It could be C, C++, it could be Rust, it could be Go, it could be even .NET. And so we've been working for a while now to make .NET run really great on WebAssembly. And with .NET in general, when we talk about web app development, historically that's always meant doing server code. Like they're all, we have a whole buffet of web frameworks that Microsoft has shipped over the years for writing web applications. Web forms, MVC, Razor pages, web pages, but they all boil down to the same pattern where the browser sends a request, you run some code on the server, it generates some HTML or some JSON in a response, and that gets rendered by the browser. If you wanted to do anything in this process, like on this user's machine with their memory and their CPU and their resources, well, that meant you had to use one of those guys. You had to use a JavaScript framework. Wouldn't it be nice if you're a .NET developer, if you could do full stack .NET web development, if you could write .NET code on both sides of the wire, so you could share code, you reuse your skill set, leverage the same tool chain, frameworks, and languages on both sides of the wire. So that's what Blazor is all about. It's full stack web development with .NET. You get to write .NET and C# instead of writing JavaScript. It's got a UI framework that comes along with it, component-based framework. So you write UI components using C# and Razor syntax. Razor is a combination of HTML and C# for dynamically generating HTML. You can share code. And also, if you have existing JavaScript libraries that you still want to use, you can, because there's a JavaScript interop mechanism where you can call into JavaScript or call from JavaScript back into .NET, all happening directly in the browser. So this is how it works. There's two modes. The first mode of operation we call Blazor WebAssembly. And this is the one that actually runs on WebAssembly, where you have the browser's core capability for WebAssembly, and then we built a .NET runtime in WebAssembly. Now this is important. With the way this works, that is actually the only piece of WebAssembly typically that's in a Blazor WebAssembly app. You're not actually compiling your code to WebAssembly. We gave you a runtime that's in WebAssembly, and then you just run normal .NET DLLs on that runtime, okay? And then we wrote a framework, a UI framework. It's in .NET, more .NET DLLs, and you write your UI components using that framework. What your components do is they render into an in-memory representation of the DOM, and then Blazor keeps track of what was rendered before and calculates a diff, and then Blazor takes care of updating the DOM for you very efficiently by detecting just what changed. It's actually very similar to how a lot of the front-end JavaScript frameworks work, like React and Angular. They do a very similar thing under the covers. UI events get sent from the DOM to your components. The components render. And we calculate a diff for you, and then Blazor takes care of updating the DOM. That's the first way a Blazor app can run, is running on WebAssembly. There's another way, which we call Blazor Server, where instead of actually running your code all the way on the client side in the browser and having to download a full runtime with it, we just run your components on the server, but we set up a real-time connection with the browser, like a WebSocket, and handle all the UI interactions over that connection. So in this case, when UI events happen in the browser, they get sent to the server over that connection really fast. And then the components handle the events. They render just like they would in the client. The diff gets calculated, but then it gets serialized and sent back down to the browser. And Blazor then has a little piece of code in the browser that applies that diff to the live DOM, and your app updates. So those are the two different hosting models for Blazor apps, Blazor WebAssembly and Blazor Server. We shipped Blazor Server in .NET Core 3.0. It's now available for production use. And Blazor WebAssembly is in preview and is expected to ship in May of next year. So that's when it'll be available for production use. The nice thing is that the same components work in both hosting models. So if you write a component, you can have it run in a Blazor Server app and then later decide, I want to use this on Blazor WebAssembly. And you can use the same component code, same assembly, and run it on Blazor WebAssembly. The component model is not different, just how the components get hosted. So which one should you use? Like, if I want to build a Blazor app, do I build a Blazor WebAssembly app, or do I build a Blazor Server app? Well, they have different strengths. Blazor WebAssembly is great if you want like offline support, if you want to build a PWA. It is full client-side web development. It doesn't need any .NET on the server at all. Like, you could take a Blazor WebAssembly app and publish it as static files to like GitHub pages or Azure Static Site Hosting. It has no server dependency needed at all. So it can support things like offline scenarios, PWA scenarios, progressive web app scenarios. It's also running completely on the user's machine, so you get that sort of zero latency UI experience that you would expect. You know, as things happen in the browser, the components are running right there, so you can do drawing apps and games that would require very high reaction times. And static site hosting works just fine. For Blazor Server, the nice thing about Blazor Server is that the client is really thin. So it can run on very low-powered devices. You don't need much on the user's device to run a Blazor Server app because most of it's actually running on the server. You're not downloading a whole runtime and trying to execute it on the client machine. You get to use the full power of the server for your application, for your UI logic, because you're running right there on normal .NET Core. You're not running on WebAssembly. If you want to talk to the database from your UI component, you can do that. I don't know if you should, but you can. You can make arbitrary network connections anywhere. In a Blazor WebAssembly app, you're running in the browser sandbox, so you're limited by what browsers will let you do. You can only talk back to server of origin. You can't just arbitrarily touch the file system, things like that. A lot of people also like Blazor Server because a lot of .NET devs are not used to their DLLs leaving the server. And they get nervous when their DLLs show up in the browser dev tools, and they're like, wait, can someone just grab my DLL and like decompile it and see my code? And it's like, yeah, they can. Just like they can see JavaScript, right? Like it's effectively JavaScript, but just in a different format. I guess you could think of it that way. So some people don't get nervous about their code leaving the server. Blazor server apps, all your code never leaves the server and it always stays there. Okay, this is how you get started with it. And if you haven't played with Blazor yet, you should. It is so easy to get started with. If you have Visual Studio 2019, the latest update on your machine, you already have .NET Core 3.0. You already have Blazor on your machine. Do File, New Project, Create a Blazor app. That's what I'm going to do in just a second. The Blazor WebAssembly preview is a separate step. You do need to call one line to install the Blazor WebAssembly template, and then you're good to go. You can do this on Windows, Mac, and Linux because there's a CLI experience for installing the SDK and the WebAssembly template as well. For tooling, we have tooling in Visual Studio, and then Visual Studio Mac is in preview right now with 8.4. For Visual Studio Code, you'll need the C# extension, and that has Blazor tooling in it as well. All right, let's do it. Let's create some Blazor apps. We don't have a ton of time. I want to show you a couple cool things. All right, so I've got Visual Studio. Let's create a new project. Let's create a Blazor app. Okay, next. Blazor app 1 sounds like a lovely name. I'm going to select 3.1 because Blazor WebAssembly also does require the 3.1 preview. So I want to play with fire. So what did I just checked this checkbox. What is this checkbox? ASP.NET Core hosted. So remember I said that Blazor WebAssembly apps, when you build them, when you publish them, you end up with just a bunch of static files, and you can deploy them as static files anywhere you'd like. There's no server component required at all. But if you use a .NET Core process to host those static files, now you've got .NET on both sides of the wire. Now you've got that full stack web development experience. So that checkbox says, not only do I want a Blazor app, but I want an ASP.NET Core app to host it for me so that I can use .NET code on both sides of the wire. Does that make sense? So now I'm basically saying I want a server component for my Blazor WebAssembly app. All right, let's create this. Okay, so what do we got here? We got 3 projects. Blazor app 1 client, Blazor app 1 server, and Blazor app 1.shared. The client project is the actual Blazor project. That's the piece that's going to get shipped down to the browser. That's the client side piece. Blazor app 1.server, that's the ASP.NET Core app. That's going to host the static files. It's going to be the static file server for the output of the client project. And it's also a place where I can stick web APIs that I want to call. Like it's basically server of origin. .shared is just a normal .NET standard class library that is referenced by both projects. So it's a place where I can put shared code that I want to be available on both sides of the wire. So for example, in the shared project, I've got my weather forecast type. Okay, and then in the server project, I have that normal weather forecast controller that you've seen a bunch of times now in some of the microservice demos. And then in the client project, we actually have this like fetch data page, which down below is using an HTTP client to get the weather forecast data from the API. And it's using exactly the same type. Like if I have 12 on this, I think it will go to the, yeah, it goes to my shared project. So we're referencing the same DLL on both sides of the wire. Okay, so let's run this and see what it does. Okay, so we've got some tabs. We can tab around, we can go forward, we can go backwards. That is all done through client-side routing. So we're intercepting the browser navigations and then just routing to the correct UI component to update the page. We're not going back to the server for each of those clicks. It's all client-side. I've got this home page with just some static content. On the counter page, I've got a button that I can click and the count goes up. Normally, there's no page refresh, right? So normally that would require running JavaScript. I didn't write any JavaScript to make that happen. I got to write only C# code. And then here's that fetch data page, which is issuing an HTTP request to the server, calling that web API, pulling down the random set of weather forecast data. It's deserializing it into an array of .NET objects and then using Razor syntax to render this page. So here's the code for the counter. It's pretty simple. So this is using Razor. At the top, we have a Razor directive to say that this component should be routable. So if someone makes a request to /counter, if they try to navigate to /counter, this component should render. We have normal HTML markup. And then here, these @ symbols are saying, you know, transition to C#. So here I want to render the value of this current count field. And then we have a button with an on-click handler that says every time this button is clicked, please call this increment count C# method, which then increments the count. When the event handler completes, the component re-renders, and then the count should be updated. And all that happens client-side in the browser. Now, to prove that that is actually the case, I'm going to set the Blazor app as the startup project, and I'm going to run it. When I run the Blazor project directly, we have a little dev server that we use to host it, so this will still work. Okay, and then what I'm going to do is if I go into the DevTools and look at console, you can see there's this thing that says debugging hotkey, hit Shift-Alt-D. So we have a in-browser debugging experience that we've enabled for Blazor apps. So if I hit Shift-Alt-D, now what this does is it will try to open the browser DevTools and it will try to connect to the tab with the Blazor app in it and try to set up .NET debugging for the Blazor app running in the browser. And it does that using the normal browser JavaScript debugging protocol, but it augments it with like a little proxy that sits in the middle with .NET specific concepts. In order for that to work, the browser has to be running with remote debugging enabled, which I didn't run this browser with remote debugging enabled, so I got to start it again. So it's telling me to do that. So I'm going to restart Edge with remote debugging enabled this time. Okay, I'm going to hit Shift-Alt-D one more time, and this time it should work. Excellent. Snap that over there. Here's the tab that I'm debugging. Now notice in the Sources tab in the DevTools, I'm seeing strange things. I'm seeing C#. Like there's my weather forecast type, and there's my counter Razor file, right? Okay, and I'm going to set a breakpoint on my increment count method. And I'm going to click. I just hit a breakpoint in C# code running in the browser on a WebAssembly runtime. Okay? That's pretty cool. Yeah, claps, all right. So down here we can also see locals. Like we can see that the current count right now is 0. Do you guys see that? See that? Okay, and then if I F8 to continue and then click again, hit the breakpoint a second time, you know, it's incrementing. So we can see local variables in the browser as well. This is an experience that we're working on. One of the reasons why Blazor WebAssembly is still in preview is because we want this debugging experience to be really good, be really high fidelity, as close as possible to the normal .NET debugging experience as we can get it. Still some work to do. We will also set up Visual Studio, the tooling, so that you can F5 from Visual Studio, and we'll fire up the browser with remote debugging enabled, connect to it through the debugging proxy using the JavaScript debugging protocol, and then you can do all what I just did here from VS. So we will enable that as well for the May release that's coming up.
Is this on all browsers?
This works, so Blazor WebAssembly works on all browsers. Mobile, desktop browsers. The debugging experience depends on the debugging protocol. So right now we've implemented the Chrome debugging protocol. And we started with Chrome because most web devs use Chrome. And we knew we needed to do Edge. And we were like, yeah, we got to do Edge at some point. And then Edge went off and used Chrome. And it was like, yes. So it actually just happens to work now with Edge. If you try to do this with old Edge, it doesn't work because we haven't implemented that protocol. But the plan right now is we will support new Edge, Chromium-based Edge, Chrome, and Firefox also is in the works. Okay, so how is this actually working? If we go to the network and refresh, let's see what this app actually downloads. Okay, and let me save with a clash, because that's not fair. That looks like nothing got downloaded. That looks correct. Okay, so if we scroll through this, we've got some HTML, we've got Bootstrap, we've got some CSS, and then you see that this stuff here. So that is the .NET runtime. It is the mono runtime that's been compiled into WebAssembly. That's what's going to execute the DLLs, which are then below. So all these guys are just normal .NET assemblies. This Blazor app 1.client.dll, that's my project, and everything else is just the dependencies of the project. We do run everything through a linker. So we strip out all the .NET IL from these assemblies that isn't actually being used. At least in the, currently we only do it for the core framework libraries. We need to get a little more aggressive, I think, with how much we link out. But that helps reduce the size. How big is the app? We go down here at the bottom. The app right now weighs in at 2.4 megabytes total. That's everything. People generally have one of two reactions to that. One is like, wow, like you fit a whole .NET runtime in 2.4 megabytes. How is that even possible? That's amazing. And it is. It's pretty, it's pretty cool. But another reaction that people have is like, that's a little big for like my JavaScript apps. I can like Webpack and tree shake down to like 10 kilobytes. Like, how can you get it down to 10 kilobytes? No, you can't. Obviously, if you care about every millisecond of load time of your app and every kilobyte of data that's being downloaded, Blazor WebAssembly is probably not going to be the best solution for you. We do plan to make this size smaller. Like I said, we plan to link more out. We have tricks where we're going to take the DLLs and try and remove all the PE header stuff from them. We're playing around with a whole bunch of stuff to reduce the size of the app, smarter compression, those types of things. I feel reasonably confident at this point that this starter template can easily get under 2 megabytes. We'll see. We'll see how far we get. We've actually been in this sort of back and forth right now where we reduce the size, but then we add more functionality, which makes the app bigger, and we kind of go back and forth on that. So we'll see how far we get, but that's where we're at right now. And of course, HTTP caching, all that, CDNs, all that stuff works. It's just a bunch of files being downloaded by the browser. So yes, you can build the app once, put it on your CDN, have people download it once, and then from then on out, they never download those files again until they need to change. So that's how it's functioning in the browser. Okay.
Is 2.4 megabytes, is that really big enough to impact performance very much though?
It really depends on your app.
Depends on your end user, if they're
Yeah.
across the other side of the globe
Oh, okay.
and they're
That's-
sitting on a
it's not very
dial-up
big.
type of
It's not very
connection.
big,
That's-
Like I said, people have different reactions.
Users, yeah.
I had some users that we talked to that were like from some insurance companies, and they said that it could be 10 megabytes. They wouldn't care because they write these web apps that download just megabytes and megabytes of data into the browser, and they do a whole bunch of processing on the client side. So they didn't care about the 10 megabytes at all. For other people, they really want that first load to be as fast as possible. This could absolutely be an issue for that.
But N640K is supposed to be enough for everybody?
That's right. Right. Okay. A couple other things. Yeah. So was there another question?
Can we bundle those files, DLLs?
Can we bundle those DLLs? So we're already, like I said, running them through a linker to strip out unused code. The IL format is pretty compact as it is. We have played around with doing IL merge strategies where you take all the DLLs and merge them into one DLL. There is some size savings from that. Not a lot, but there is some. Problems with that then is like, anytime one file changes, then the whole bundle changes, and so your caching strategy would then be different. Like you're invalidating the whole cache for that whole bundle at that point. It's possible. It is one of the things that we have played around with. I think we're leaning away from doing IL merge because it also tends to break some other assumptions that .NET libraries tend to make about identity of the assemblies. Like the identity of your assemblies is generally important to some code in .NET applications, so we might want to preserve that. We'll see. We have from now to May to get that as small as we can possibly figure out how to do it. So what does it look like to work with components? So each of these .razor files is a UI component and it's reusable. So for example, if I want to add like another counter to my homepage, you use HTML element style syntax. Similarly, if you want to have parameters for your components, like you want to flow data into them, that's as simple as defining a property on your component. I'm going to call this one increment amount, and I'm going to default it to 1. And to make this a parameter for my component, I'm going to attribute it with the parameter attribute. And now, instead of incrementing by 1 every time, I'm going to increment by increment amount. And then if we go back to my home page, I should be able to get IntelliSense over that. Yep. And so there's increment amount right there. You can see that. So let's make the counter on the home page increment by 10. And then the counter that's on its own tab will keep incrementing by 1, hopefully. Let's see. That works. So here, I don't know if you saw that flash by, but like all this is the linker running through the assemblies and trimming out all the unused code. So now, yeah, my counter on the home page increments by 10. My counter on the counter page increments by 1. We could do class libraries that have components in them. In fact, a lot of our component vendor friends, like Telerik, DevExpress, Syncfusion, Radzen's another one. They're busy. They've already shipped libraries of Blazor components. So if you want to have like a grid or a tab view, it's as simple as installing their NuGet package into your Blazor app, and then you just put a teller grid on your application, just like you would with other component-based UI frameworks. So that was a Blazor WebAssembly app. I should show you a Blazor server app just so you get a feel for how that's different. So, Blazor server. Okay, so here with Blazor server, we just have one project. That's because, well, everything's running on the server. Like the components now are part of the server process. We're just setting up a pipe, like a real-time communication channel with the browser for handling all the UI events. So if I run this, okay, so this app has the same functionality, like the user experiences the same stuff. And we can go forward and backwards, we can click the counter, but what it's doing under the covers is different. So instead of running on WebAssembly, if we look at the network. So that's the whole app. So this app is 423 kilobytes, so much smaller, so faster load time. We're set here. You notice there's no WebAssembly in this list. There's a server.js script instead of a WebAssembly.js script. And down below, there's this underscore Blazor request, which was a WebSocket request. And here we can see the binary messages being sent over that WebSocket. So if I clear this and then start clicking, see that? So every time I click, we send a little packet to the server to say, hey, this button was clicked. Counter component, handle it. And the counter component renders, Blazor then figures out what changed in the UI from what was rendered previously, serializes the little diff back to the client, and you can see these packets are tiny, like they're bytes, they're not kilobytes. And that's important for keeping latency down as much as possible. So with a Blazor server app, you do obviously need a server component. In fact, you're paying with your server to run the UI of every client that connects to your app. Every client that browses to your URL is going to set up a WebSocket connection with you. And then you're going to be rendering the UI for the client and then just sending them the DOM updates. So it's the scale out model obviously is different. You're not offloading the UI to the client. You're saying, I'm going to handle it for them, which means you can the UI can now work on much lower powered devices, but it also means there's more cost potentially for you. Now, how well does that scale out? A lot of people ask us something like, how well does Blazor server actually scale? So we do our own load tests with Blazor server apps. With a Azure D1 V2 instance, with active clients where they're just basically clicking on the counter every second, you can handle 5,000 concurrent clients on a fairly small instance. One virtual CPU, just a little under 4 gigabytes of memory. If you have a larger instance with 4 virtual CPUs and 14 gigabytes of memory, you can handle 20,000 concurrent clients, all active at the same time, clicking on links. So when you think about Blazor server apps, you have to think, well, what kind of usage do I expect? And you'll need to plan out your server resources accordingly based on how many users you think you'll have, active simultaneous users. The main bottleneck tends to be memory. Each client by default, like as a baseline, will take about 250 kilobytes of memory from just the Blazor stack. And then whatever you add on top of that with your application code, that's kind of how you can think about, well, how much oomph do I need in my server? How much server memory and server compute am I gonna need?
Will Blazor server work on Linux as well?
Yeah, absolutely. Yep, it's the whole stack is cross-platform. Okay, in my last 4 minutes, I want to show you some future thinking things. Stop this. So let me jump to this slide. So we're now on a journey. We've been working on taking Blazor .NET to the web, like to the browser. And now we're starting on a journey for taking Blazor to more native app development. So I just showed you Blazor server. That's like the most classic .NET web app you can think of, but with a twist. It's running on the server, rendering things on the server, but using a WebSocket connection instead of normal HTTP requests. I showed you Blazor WebAssembly. Now it's running at least on the client's machine, albeit in the browser security sandbox. Can we go even more native? Well, the next click stop might be to turn that Blazor app into a PWA. PWAs have native like features, like you can pin them to your home screen on your phone because they have a manifest with what icons to use when you're pinned. Or in Windows 10, you can install them so that they show up on the Windows 10 start menu. They can work offline because you can add a service worker that caches the files. They can do push notifications and all those types of things. We could do that with Blazor as well because Blazor is just a web app. Moving down, Blazor Hybrid, that would be, hybrid apps are native apps. Like they run natively on the machine. They're no longer in the browser, but they still use web tech to render the UI. So an Electron app is an example of this. An Electron app is a native app, like it has access to the file system and the resources of the machine, but it's using an embedded Chromium shell for its UI needs. That's a hybrid application. Ionic or Cordova in the mobile world is an example of a hybrid app. You could do something very similar with Blazor. You could have Blazor run on .NET Core on a desktop and render to Chromium shell, like an Electron app does. Or you could have Blazor running on the Xamarin runtimes on iOS and Android and rendering to a web view. And then lastly, you could imagine even going full on native, where instead of using Blazor to render HTML, you render native UI controls. How many of you have heard of React Native or Xamarin Forms also? Like those are stacks that are cross-platform UI stacks, but what they're really doing is giving you an abstraction over the native controls of the OS. And so you get a common way to write like a native button or a native text box. So let me show you this one. Last app is the last demo. And then I will do that. Let's go. So this app is a Blazor app hosted in 4 different ways. So it's a weather application. Okay, so we see we got 3 different app projects. We got a Blazor server, Blazor weather server, Blazor weather WebAssembly, Blazor weather Electron, and then we have this core project. So here in the core project is where all the components for this app actually live. We got all these .razor files that are defining the UI for these applications. But the apps themselves are just shells. Like they don't really have anything interesting in them other than that they reference that core library. Okay, so let me show you what this app does. So here's the Blazor server version. And we can, see what's the weather in Seattle. 52 degrees apparently. What's the weather in Honolulu? So this is using the AccuWeather APIs behind the scenes to make requests to pull down weather data. We get some SPA-like functionality here to change from Celsius to Fahrenheit. We can pin different locations and store them in local storage in the browser. That all works. So this is running over the WebSocket connection. Okay, same UI components. Let's set this as the startup. But now running as a Blazor WebAssembly app. All right, so this still should work. Chicago. Okay. On this one now, if we went and looked at the network, like this has got, there's mono.wasm coming down. Like this is a WebAssembly application. Where should we like St. Louis? There you go. There's the arch. 32 degrees in St. Louis right now. Okay. So that's an example of using exactly, like it's literally the same assembly being used by both the Blazor server and Blazor WebAssembly to render this UI. Okay, but we can also reference, and before I do that, notice up above, there's this button here that says install Blazor Weather. You see that? Why is that there? Well, that's because the Blazor WebAssembly app does have 2 things. It has a manifest and it has this serviceworker.json file. Now, some people look at serviceworker.json and say, like, hold on, you told me I didn't have to write any JavaScript. Well, service workers are basically recipe-based code. Like you typically search on the web, like I want a service worker that like caches, like goes to the web first and then caches. And then you get a piece of JavaScript and you copy it into your app. So that's the level of JavaScript writing you had to do to get this service. But because those files are there, the browser notices, oh, this is a progressive web app. I can install this. Sure, yeah, go ahead. So now it's got like a native Windows shell. It still works. You can see what the weather's back in Seattle again. And it shows up in my start menu someplace. Yep, see there it is. There's my start menu. So now it's a PWA, starts to feel a little bit more native. And here is Blazor app, the same UI components, but instead of running in a browser, these are now going to run in a .NET Core process and use Electron for the UI. So same components again, still HTML, CSS, but now the runtime is .NET Core. This app can access the file system and do all sorts of native things if it wanted to, but the same functionality still works. So I don't know, it's cool. Okay, so that's a hybrid app. That's Blazor hybrid. And then lastly, the crazy one is so the Blazor Electron app that I just showed you we have a sample app on GitHub that you can look at if you want to play around with using Blazor with Electron. It's not an official preview. It's something that we're experimenting with. And then internally, we have a prototype of using the Blazor component model, but with native UI controls. So here in this version of the weather app, so we have, this is the Razor file for this application. You notice it's not HTML. It's got like a content page and a pancake view. These are Blazor component wrappers around native controls, basically the Xamarin Forms abstractions, but done with Blazor components. And ignore that. That'll be fine. It'll be fine. It's just part of doing running prototypes sometimes. All right, so I'm going to run this. This will host this Blazor application in a Android emulator and should give me native UI. Let's see.
So how is this not the spiritual successor to Silverlight? I'm gonna be that guy.
Yeah. So, great question. I get the question all the time. So Silverlight was a way to run .NET in the browser. Silverlight required a plugin into the browser in order to actually enable the .NET execution. Silverlight was also, it's proprietary. It was not open source. It was a Microsoft thing, and then we basically stopped investing in it. And anyone who was doing Silverlight was like, shoot, like what am I supposed to do now? Blazor is completely different in that it's completely based on open web standards. Like nothing we're doing requires a plugin. It all runs in the browser normally without any extensions or any of that stuff. Everything we're doing with Blazor is public and open source. So you can build the entire stack end to end if you wanted to and run with it. In fact, other companies are doing that. Like there's a company called Uno that took the same WebAssembly runtime that we built, and instead of using the Blazor programming model on top, which is more of an HTML, CSS style programming model targeted at web devs, they built a XAML-based programming model on top. They basically took the UWP programming model and made it work in the browser using that same runtime. So you can do stuff like that with Blazor. If Microsoft were to back away and say like, we're kind of tired of investing with Blazor, of investing in Blazor, the community can still carry Blazor forward. So it has that inherent longevity. I also think, as I'm trying to show here with this like sequence of hosting models, we have a bright future plan for things that we want to do with Blazor. We're trying to get, we've already shipped Blazor Server. We will ship Blazor WebAssembly in just a few months here. Blazor Electron, we expect to have like a public preview within the .NET 5 timeframe. And then Blazor Native, we don't have a roadmap for yet. I don't know why that failed to deploy. I guess maybe those errors were actually important. But the app, fortunately, was already installed previously. And you can see this is slightly different. This is not the same UI controls, obviously, because it's not HTML. Like the components used by the other apps were HTML and CSS. This is using native controls. But you get to use the Blazor paradigm, the way components work, the way parameters work, the way Razor syntax work. You get to reuse that knowledge as a web developer now to build your native mobile application instead of having to learn, say, XAML if XAML's not your thing. So that's Blazor Native, and 6 minutes over. I'm sorry for keeping you longer, but that's what I had to say about Blazor. And if you want a summary of that roadmap, here's the .NET schedule coming forward. We're basically shipping a major release every year. We just shipped 3.0 a few months ago, and 3.1 will ship in November of 2019, which is just in a couple weeks. And we'll have a major release every year from there. .NET 5 should be a big release for us because we're going to be like merging Mono and .NET Core in all sorts of interesting ways. The Blazor WebAssembly release will be tucked in between. Like we're going to ship that as an out-of-band release on top of 3.1. And that's what I've got for you. Thank you for sticking around and listening. Try out Blazor.
I've got a question. So on On server side versus WebAssembly, the
Yeah.
project type, the layout of the projects look completely different. If I made a server side and wanted to try WebAssembly and see how it performs